This lesson has dealt with velocity and acceleration and displacement, and now we're going to do the same thing but in a different context. So we have talked about this before, and it has to do with the fact that the area, let's talk about the squirrel again, the area under the curve of velocity will tell me my displacement, right? So in this context of what's happening, the integral of velocity tells me how far. And we're going to extend that idea. So here goes. The integral of a rate with respect to whatever time is going to give me a quantity. That doesn't necessarily go in an official calculus memorize this box, but please memorize this. Please know it. Don't just memorize it. Know it. The integral of a rate gives me a quantity. And that rate, depending on the context generally, but that rate, if it was velocity, would tell me miles or kilometers or whatever distance. That rate, if it was water pouring into a tub and it was gallons per minute, the integral of gallons per minute would give me gallons. That's what's going on. So the net change, that is the change of a quantity from A to B. The net change from A to B of the quantity F. Okay, so we have some function that represents a quantity. The rate is given by its derivative. That's old stuff. We know that. Derivative is a rate of change. It can be represented as, let's stick with green, the integral from A to B of f prime of x dx, which is the antiderivative of the derivative, which is f of b, and then minus f of a. You've seen this. This is the fundamental theorem of calculus. But now we're putting it in a context where I'm saying with word problems, we have a rate. Next problem. Water is leaking from the tank at this rate. How much water is lost? What is the net change between the third minute and the sixth minute? Okay, find the antiderivative, plug in a 6, plug in a 3, subtract them, and you know how much water was lost because the integral of a rate gives me a quantity. So let's do it. How much water was lost? I'm not telling. From 3 to 6 of my rate, which is this. And then I'll take the antiderivative. Let's go old school for just a minute. So 3t, and then plus, let's see, that's t squared. That's 1/2. 1/2 divided by 2 is 1/4. We'll stick with decimals. So 0.25 t squared. Piece of lint on there. There we go. Got it. From 3 to 6. So we do 3 times 6 plus 0.25 times 6 squared. That's the first part, and then minus 3 times 3 minus 0.25 times 3 squared, and that's the second part. And I'll just jump straight to the answer at this point. We are dealing with gallons per minute. The integral of a rate gives me a quantity, so this is going to be gallons, and the number itself is 15.75 gallons of water. Let's finish the word. Gallons of water that are leaking out between minute 3 and minute 6. That's how much leaked out. Let's move on. This one can trip you up if you're not careful. There's a lot of information in this one. The number of barrels of oil in a warehouse is modeled by the function B of t, where t is measured in days. Okay, good to know. B is the number of barrels of oil in a warehouse. We don't have the exact function. It's not like, B of t equals e to the x times cosine of, and we don't know. The derivative is known, but they don't tell us. And it's also known that b of 4 equals 54. All right, let's just talk about what we know without even reading the first problem. There's a warehouse. There's oil in there. Barrels of oil. The number of barrels of oil at any given day is given by a function that we don't know. And we do know the derivative, but somebody's just not willing to tell us for whatever reason. I don't know. I think they should be interrogated. And then we also know that, this is good to know, on day 4, there are 54 barrels of oil in the warehouse. I would say at the end of day 4, there are 54 barrels of oil in the warehouse. So, let us move on. What is the meaning of this? I don't know. No, I do know. I know, and so do you, and I'm going to bump the table about it. So, there we go. I kept bumping the table. I'm not sure if you saw it. There we go. Oh, no. The whole warehouse is shaking and the oil is falling everywhere. What we're going to be doing is finding the integral of a rate. It gives us the quantity. Okay? From 0 to 3 days. Let's just start writing. From day 0 to day 3, and we'll pause and think. The integral of our rate gives us a quantity. The rate of change of the barrels of oil, when integrated, tells us the number of barrels of oil. So 418 barrels of oil. Now you're probably thinking, it's negative. I know, we're working on that. Were removed. That's why it's negative. That's why we have negative numbers. From the warehouse. Okay, we've put units in there. We've interpreted from day 0 to day 3. We lost 418 barrels of oil there. Good to know. What inferences can you make from this equation right here? I don't know. Actually, we can do a lot. Let's actually use some information that they told us. So 42 equals B of 4. Oh, 54. Good to know. Good to know. Yeah. Plus the integral from 4 to 9 B prime of t dt. So we'll move the 54 over. We end up with negative 12. And then from 4 to 9 B prime of t dt. We get that. So basically we're interpreting this the same way we interpreted that. There's a little bit more we're going to talk about in this in a minute, but let's use another sentence, write another sentence, just like we did on the last one. So from day 4 to day 9, 12 barrels of oil were removed. We'll just leave the sentence there. Okay, as I was working through the answer key to this problem, and I'd kind of written it to try to get all the nuances, I realized one more little nuance that I think is worth pointing out, and it is the fact that we can take this idea, this equation, and use this idea with it. So just watch this. I'm going to switch colors. Red. No, red just makes me look like I'm angry. I'm not. I'm just going to bring this down here and rearrange a few things. So 42 equals 54. Why am I doing this? You'll see where this is going in a minute. And I'm just wanting us to have a discussion, a one-way discussion through a video. If I rearrange a few things, then I'm going to have, let's just do this. Let's switch sides. So nothing algebraically too crazy yet. There's this, and the t equals, and then 42 would be on the other side, and then we'll subtract 54. Now, I know you're like, you did that, you got negative 12, what are you even talking about? I want to point out the similarities between what just happened and what is happening now. So here's what's happening now. Here's what happened 8 minutes ago in the video, pretty much. So the integral of a rate gives me this, which means, well, 54 was B of 4, right? So if this right here was B of 4, then this must be B of 9. So when they said, what inferences can you make? Okay, well, we did that, but now let's make inference number 2. At the end of day 9, and I say at the end of day 9, otherwise this number might not be 9, it might be 8.5 or 8 point whatever. So at the end of day 9, not a huge deal, but end of day 9, there were 42 barrels of oil in the warehouse. Lots of stuff you can find from that. Okay, 2 things you can find from that, but it's a very rich formula.